Hello and welcome. So we're going to be talking about circles a little bit more today. So the problem we're looking at here is a bit of a word problem, but it's not too scary. So we have a semicircle here, forming from an arch, and then we have a black support beam within this semicircle that we know is a length of 3.6 meters. And that bar is a 2.7 meters distance from the surface of the water. All right. So when we're looking at this, our goal, before we worry about any other measurements, is that we're looking for the diameter of the arch. So let's kind of take it out of the drawing a little bit to see it easier. So we have ourselves a circle. Right, and then we have some kind of support arch there, and we know that's 3.6. Right, and then we have our center of the circle. Right, that's going to be where that distance from the beam to the center is. All right, and that's what we know so far. So our goal is to find the diameter of the arch. Now remember, a diameter is essentially the distance from one end of the circle to the other that passes through the center. All right, so our goal is the diameter. Now, the diameter is all well and good, but remember, relationships as far as diameters are concerned is that we know the distance from the center to the outside is the radius, right? Which means twice the radius is your diameter. Right? So what we really need to find here is our goal is what is the radius of my circle? Because once I know that, all I have to do is define my diameter. I'll essentially multiply the radius by 2. Okay? So looking at properties, we know that from the center to the black beam is 2.7. Now that is going to hit a direct vertical, kind of like a perpendicular distance to that beam. That's going to be a right angle right there. And what that allows us to do is use a couple of our circle properties, knowing that, hey, if that is a right angle intersection, then that means that this can be split directly in half. The point where that 2.7 hits the 3.6 beam, right, that is the midpoint. So we can break that 3.6 apart and say, okay, well, I know that half of that is going to be 1.8. So that means the distance from here to here is 1.8. Likewise, that distance is 1.8. The total is 3.6. And then all I'm going to do is I'm just going to finish that off. So I know, let me kind of shrink that 2.7. 2.7 is that side right there. 1.8 is going to be the top, which means this last piece, right, is going to be my radius, because that's from the center of the circle to the outside of the circle. So what shape does this form? Wink, 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 wink. That's a triangle, and more than that, because I know one side, the other part of that 180 is a right angle. That means that's also a right angle. That's a right triangle. Ooh, hopefully you kind of see where we're going next. Pythagorean theorem. We know 2 out of the 3 sides of this triangle. All we have to do is just fill in what we know. All right, Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared. Right, and so we're looking at the 2 legs of my triangle, which is 2.7 and 1.8 in this case. So 2.7 squared plus 1.8 squared equals the hypotenuse of my triangle, which is my radius, squared. And then we just have to simplify. All right, so in calculator, I'm doing 2.7 squared, we get 7.29, and then 1.8 squared, we get 3.24 equals r squared. Combine those two numbers together, so 3.24 plus 7.29, and we get 10.53 equals radius squared. We just need to finish solving for the radius, right? Our radius is squared. We undo squares with square roots, right? So we take that. Now remember, square root means plus and minus, but keep in mind we're talking about real, like tangible lengths. You can't have a negative length. So while there is a plus minus, we're only going to work with a positive of those two. So r equals that square root. Now, for this one, remember your goal is the diameter, so I'm going to just straight up finish solving. And I'm going to say, okay, well, radius equals the square root of that thing, which means my diameter will be 2 times my radius, which is that square root. And this is what I'm going to plug into my calculator. All right, so come back here really quick, clear what I have in there out. So we have 2 times my square root of 10.53, and we're getting 6.48999. Now our goal is usually third decimal place. Let's double check what this one says. Oh, nearest tenth of a meter. Easy. So that's the first decimal place. So we have 6.489. Well, 10th decimal place is first, so we look at the second digit, which is an 8. 8 rounds up. So 6.5 would be to the nearest tenth of a meter, the diameter of the arch. All right, and that's it. That's as crazy as this is. So don't let the diagram freak you out. I would just honestly put it into a circle to make your life a little easier, right? A little easier to recognize, I should say. But that's all there is to it. Thank you so much for watching.